Hey guys, welcome to my channel Tech Bytes. In this session, we are going to explore Quicksort and its implementation in Java. Quicksort is the most popular sorting technique among all other sorting algorithms. The reason being its efficiency because its complexity is order of n log n. Its efficiency is quite high when the size of the list is large. Java uses this sorting technique for some of its available functionalities like arrays.sort. Certainly, there are some other functionalities as well. So let's see how it works with an example. Suppose we have an array of numbers 40, 60, 20, 10, 50, 70, 80, and 30. So the logic here is we need to select a pivot element. Here, pivot element could be any element in the list. Here I have chosen 50. The goal is to compare all the items to the pivot element. Gather the smaller items to the left of the pivot element and larger items to the right of the pivot element. Alright, in other words, take the pivot element 50, scan the list from both left and right. The item larger than the pivot from the left and the item smaller than the pivot from the right should be swapped. Okay, so here the pivot element is 50. I'm scanning from the left. 40 is smaller than pivot element. That's fine. We can proceed. Then comes 60. 60 is larger than pivot element. Okay, so we cannot move forward. Okay, 60 is the element that needs to be swapped. Okay, then again scan the list from right. 50 is compared with 30. 30 is smaller than 50. So now we can swap the element 30 and 60. Okay, so if you look at the list at the bottom, both 30 and 60 are swapped. So the list looks like this: 40, 30, 20, 10, then the pivot element 50, 70, 80, and 60. This process has divided the list into two partitions, left partition and right partition. Okay, and lastly, repeat the steps recursively for each of the partitions. All right, now let's see with another example. Say we have a list 33, 22, 77, 18, 19, 12, 92, 57, 21, and 69. Here I would like to choose pivot as 69, just to show you that we can choose any element as pivot element. All right, so now let's start scanning from the left and right. All right, so 69 compared with 33, it's fine, it's smaller. Then 22 with 69, it's fine. 77 is greater than 69, so we need to stop here. Again, start scanning from the right. 21 is lesser than 69, so we need to stop here. So, thing is, we need to swap 21 and 77, right? So, see in the next step, 21 and 77 are swapped, so the list looks like this. All right, then continue scanning, continuing the same process until your left pointer and right pointer both meets. So 69 again compared with 18, that's fine, it's smaller. Then 99 compared with 69, 99 is bigger, so we need to swap, we cannot proceed, need to stop here. Then let's scan from the right, 69 compared with 57, we should stop here, we need to swap. So after swapping, the list looks like this. All right, so here 57 and 99 are swapped. Now it should continue 12 and 92. This process should stop when our left pointer meets right pointer. All right. So in this process, we got 69 at its right place and got left partition and right partition. Same process, we need to continue with left partition and right partition. From left partition, maybe we'll have another two partition, and from right partition, we'll have two more partitions. Those subpartition again will continue. This whole process will continue until we find there is no partitions, and that time the list will be sorted order. Alright, as it is mentioned, pass 1, 69 found its position, and now we have two array lists which are not sorted called left partition and right partition. Alright, so what are the important points? Quicksort works on selecting a pivot element in each iteration. It follows the divide and conquer principle. We divided into left partition and right partition number of times, and it's recursive. What are the advantages? Advantages are it is faster, and disadvantages may not be useful when the list is too small. When the list is too small, maybe it is not so significant. It might be same as bubble sort or insertion sort. All right. And the time complexities are best cases order of n log n, average n log n, and worst cases n square. Now let's see the coding part. Here is the program for Quicksort. I have taken an array of numbers, all right, and sort is the method. I'm passing the array of numbers to sort. Here what I am doing in sort, I'm checking whether if elements are null or elements length equals to 0, I'm returning. Alright, here I just copied that list into a global list, you can say, okay, and calling quicksort. And basically I'm passing the range of index of the list starting from 0 till the last index. Alright, so how it happens in the quicksort? So the two pointers, two indexes, start and end. Alright, so what I did, I'm not changing start and end. Instead, I'm copying start and end to forward and backward pointers. Alright, then pivot, I'm selecting pivot. You can select any number as your pivot element. Alright, so how I'm doing, I'm continuing this loop until the forward pointer is less than the backward pointer. Alright, then inside that, I'm comparing pivot element from the left side of the list. So that is my forward pointer, and increments the forward pointer so that it will stop when the pivot element is less than the number. Alright. Similarly, I'm comparing the pivot element from the right side and decrementing the backward pointer so that it will stop when my pivot element is lesser than the number. Alright. Then after that, so my forward pointer is set, backward pointer is set. Okay. So after that, what I am doing, I am comparing if forward pointer is lesser than backward pointer, swap both the elements. Okay. So for swapping, I have written another method. All right. After swapping, I'm just moving one place forward pointer and one place backward pointer. Then this loop continues. All right. So this loop is basically for one iteration. Then it checks if start less than backward, quicksort start backward. This is basically calling the left partition. Then if forward less than end, quicksort forward end. This is basically calling the right partition. All right. This is it, guys. Please let me know if you have any questions in the comment section. For the sample code, you can refer to my GitHub account mentioned in the note. Thanks for watching. I'll see you at the next one.